For the following reaction, listed there, we have a delta G standard at 298 value of negative 5.4 kilojoules. So when you mix a certain amount of our nitrous oxide and a certain amount of our dinitrogen pentoxide, which way does the reaction proceed? So this is a kind of one that we haven't actually seen before, but this is exactly the style of a question. When it's asking which way will the reaction proceed, this is when we're looking for that left or right. We're looking for spontaneous, well, should match these, non-spontaneous to the left or spontaneous to the right. Which way is the reaction going? Because remember, whenever we say spontaneous, we're really talking about spontaneous in the forward direction. Forward being, again, to the right. So if we want to know which way that proceeds, and we're given some various values, what we really have right here is we really have Q, and we're asking about delta G. You can also think that, well, we're really asking about equilibrium, which way is everything going to shift, but we haven't been given a K value here, we've been given a delta G value, a delta G standard value. So for this question, what we're going to do is go ahead and use our equation. Delta G equals delta G standard plus RT natural log of Q. So you can see that this is really, our delta G is going to be what we're looking for. We've been given this value. And since we already have that delta G at 298, we have our temperature. Our gas constant, we're going to be able to look up in a table on that back page of potentially useful information. You'll find it's 8.314 joules per mole Kelvin. So that's one of those things that's in a table that we can look up. Our temperature, that's going to be our 298. That's in Kelvin. And this is also from the question, negative 5.40 kilojoules. So this already looks kind of messy. So we're going to go ahead and take a moment to rewrite this. As I rewrite this, I'm going to note that I've got something in kilojoules here, something in joules here. So I'm going to go ahead and just move everything to one of those. I'm going to pick joules. So now I have negative 5,400 joules plus my 8.314 joules. So now my units match, times my temperature, times the natural log of Q. So we haven't actually solved for Q yet, but we can look back up at our question and we can figure Q out. This is not so bad. So again, you're going to have to rack your brain a little bit because it's been a while since we did Q, but if you'll remember, Q is going to be from our chemical equation up at the top, the products over the reactants, using our coefficients as exponents. Now, you'll notice I went ahead and did that in concentration. That's out of habit. What we actually have here is we have a lot of pressures. So the way that we can certainly rewrite this, it just always gets a little bit messier. So we've got subscripts within subscripts. The pressure of the partial pressure of the products divided by the partial pressure of the reactants, and then everything, this guy, is squared. Regardless, we can plug in those values, 0.6 divided by 0.25, squaring this bottom number. So after all of that's said and done, we'll get a value for Q of about 9.6. So we can go ahead and plug in delta G negative 5,400 plus 8.314 times 298 times the natural log of 9.6. Taking this step by step, we've got our negative 5,400, and once I take the natural log of 9.6, that number is going to be 2.26. So when I add all this together, I'm going to have a positive 5,603.68. This is where it's nice to remember that you need to keep your negative signs and positive signs straight as we go through, because that's going to make a difference in our final answer. So you don't just get to drop the negative sign. We need that too. So you get a final answer of delta G equals 203.68. Since this is a positive value, that's going to be non-spontaneous. And whenever we say non-spontaneous, we do mean non-spontaneous in the forward direction, which, as you might imagine, that means it is spontaneous in the backwards direction. So this reaction is going to proceed to the left.